All right, so in this next part, what I want to do is go through each one of these definitions more precisely, and then we're going to start looking at some examples how to apply it. So the first thing here is data. Basically, data is what's being collected. In mathematics, we refer to this as a set. There's no end to what can be collected. When we start talking about our variable, this can be numerical or, for lack of a better sense here, we'll redefine this, but I'll just say non-numerical. So numerical, non-numerical. So data is what's being collected. Grams, ounces, feet, pounds, favorite color, favorite pizza toppings, favorite, anything, who are you voting for the president in November. I mean, on and on and on. Data is endless. Anything can be data. Variable here basically happens in two parts. So a variable, something that varies, can be numerical in nature. And as I went through this, examples of things that are countable. So you're going to say numerical or categorical. So numerical is a number with quantity. And what I mean by that is versus something that's categorical. The name on a sports jersey goes along with a certain number on there, and usually the numbers are defined as the person's name. So numbers on a football jersey, here we're going to start football season pretty soon here. Actually, it's already started. So categorical is basically, it's not a number. It can be a number, but it's a number that represents a person's name or entity or something in that way. And that's why you have the distinction here that categorical can be numerical too, but more specifically, in a numerical setting, it has quantity value. So jumping back over here to categorical, and more or less we're looking at qualitative data, non-numerical. Or a number with representation. I was tutoring a student, thought probably go to grad school or something like that, doing a little project, and figured that they could mark men and women with 0 and 1, which is fine to do that. But the only thing that I have with that is that you can do that, but you can't order the set. So numerical values can be ordered, and there's a different levels of types of data, ratio level, different types of levels there. But in a sense of when you're representing a person or entity or an object with a number, again, going back to the concept of using a number that represents on a football jersey for their name, that's not something that we're necessarily going to want to do any math with. So that's getting extreme there, but to keep it very simple, a number for numerical, non-numerical for categorical. Let's go down the next one here, population. Population, again using the word all there. So it's the set, let me come back here, the set of all outcomes. slash, I'm going to put here responses. That's a population, so it's everything. That's the key word to that is the word all. Wherever you're defining your population, again, the college, Kings County, Tulare County, the people that live on your street, however big or small you're defining your population, but the sense that is collecting everything. Now down here below is the word sample. So I have to outline these first. Very simply here, sample is a, let me come back here. It's a subset, meaning part of, subset of the population. So population is all responses in feet, inches. Say I took everybody in the classroom, asked them to weigh on themselves on the scale in the morning. Then a sample of that is a few of those weights in pounds taken. So what we're going to start doing is looking at keywords that go along with down here at the bottom. Keywords like average and proportion outline what these things are, parameter and statistic. But kind of like what I said in my last video, notice that the word population begins with the letter P and parameter begins with the letter P. That's a very important distinction because tag teaming that with sample starts with the letter S, also goes with statistic. So in the concept here, when I'm looking at a population and it's looking at also the word all, so does a parameter includes the word all. So when I start looking at examples, make sure that parameter, if it's the letter P means everything. Letter P goes with all. On the other hand, sample and statistic are the part, and usually that's going to be some sort of discrete number, a countable number, a part of everybody, the whole thing. So for here, a parameter, again, as I defined that earlier, it's a number that describes the population. Notice I had the word P in there. Population. Parameter population. Population is all responses. The parameter is a number that represents all responses. That could look like in the form of, for example, average is a parameter. Min is a parameter. Maximum is a parameter. Proportion is a parameter. Think of like proportion is the same thing as percentage. And on and on. So there's many different values or numbers, but it has to be a number that represents that group there. That represents a population. On the other hand, down here, a statistic is also a number. So it's a number that describes the sample. That describes a sample. What is a statistic? Again, it's a number, all these things. I'm going to grab all this that I just included here for my population. Those also can be considered a statistic. Average, min, max, proportion, percentage, variance, standard deviation, there are so many different stats and parameters, but the distinction is, again, here with the letter S. So S, statistics, sample, parameter, P, purport, or population. So these are very vague concepts. However, this will make sense as I go through more examples here. Last few here, descriptive statistics. Again, like in the other video that I described that as, again here, quote here, just the facts. Dot, dot, dot. Again, just the facts are, say for example, our statistics. That is a perfect way to represent what we know as descriptive statistics. Along with that too are graphs. So graphs of all kinds, time series, bar graphs, pie charts, all that stuff there is describing what's happening, ordering the data, descriptive statistics. Now, last part here, inferential statistics is where you start to draw conclusions. So conclusions are drawn from the, up above here, drawn from the descriptive statistics. Conclusions drawn from the descriptive statistics. So that could imply that many things, that we would say that women are taller than men in this environment, men are taller than women, or whatever. So as long as you're not stating any numbers or, basically things that are true about what's represented, when you start saying something about your population that way, that's where we start to go inferential statistics. So just keep in mind here, basically you're drawing conclusions and saying something about your population from the stats there, descriptive moves into what's called inferential statistics. Okay, so that will do this part here on just the basic definitions of getting this set up in this section 1.1.